Hello, friends. I hope you are doing well. I'm just finishing up the last two problems on your homework, on the notes. So I just want to make sure we had those. On example 6 here, we want to make the lines parallel once again. Well, remember, if I want them to be parallel in my head, I have to imagine that they're parallel. And we know these two angles are same side interior angles. So in order for parallel lines to happen, same side interior angles have to be supplementary. So we're going to go literally x squared plus 3x equals 180. Now, the moment you see the x squared and the x, you should think a quadratic equation. So I'm going to use factoring to solve this, or you could do quadratic formula if you do it right. A lot of people don't do it right. So one thing you need to do, anytime I'm solving with a quadratic equation like this, I need to move everything to the left side. Then you look for a greatest common factor. Well, there is no greatest common factor. We have an x squared, 3x, and 180, but that's it. So I have no GCF, so I go to my two sets of parentheses. With that, we have a negative 180, which means I have different signs. I have an x and an x here. And then you have to think of like your factors of 180. Now, obviously, you're going to start thinking like 9 and 20. 11 doesn't work. 12 works, though, and you get 12 and 15. So 12 times 15 is 180. So with that, I'm going to put 15 here and 12 at the negative. Remember, I have to check to make sure I did this right. So again, negative 12x, a positive 15x, and I get a positive 3x. So that meant we factored correctly. Then we set them both equal to 0. So x plus 15 is equal to 0, and I get x minus 12 is equal to 0. So I get x is equal to a negative 15, and I solve and get x is equal to positive 12. Now, again, context of the problem, x has to work in my problem. So that's one thing with geometry problems is I got to go and check my answers. Well, I'll tell you right now, negative 15 does not work because if I plug it in for this angle, I get 3 times a negative 15, which gives me a negative 45 degrees. Do I have a negative angle there? No, we don't have negative angles until you get into pre-calculus world. But right now, I don't have a negative angle. So that's not a valid answer for this. So it's gone. Now double check to make sure the other one still works. Yeah, I get 3 times 12, which is 36. And I get here 12 squared, which is 144. Well, 144 plus 36 adds up to 180. X equals 12 is my actual answer. Now again, you've got to remember some rules to do this. I had to remember what same side interior angles do. They have to add up to 180 to have parallel lines. All right, now we're going to do the next one. It's a little bit of fun. It's a proof, and I think it's a fun proof. But remember with all proofs, what you put down many times in the previous step kind of guides you what to do for the next one. So with this one, it says fill in the missing statements or reasons for the given proofs. So first things first, we're going to write down. Now you could go in different order. That's totally okay. But I'm going to go with the fact that I have parallel line segments first. So I get the fact that segment BA is parallel to segment DC. And that's just given. So I know these two are congruent. Now, if those two are my congruent lines, right here and here, doesn't that make BC a transversal? Do you guys see a zigzag shape? Do you see the Z shape? Well, I see the Z shape, so I can go ahead and talk about how angle B and angle C are going to be congruent to each other. So I get here, angle B is congruent to angle C. Oops, I put the wrong angle down. Angle C. Because if I have parallel lines, then alternate interior angles are congruent. That or you're going to have to tell me the alternate interior angles theorem. All right, so we have that. Okay, I'm kind of stuck again because remember my goal is to show, I want to show these two lines parallel. But do you notice there's only one transversal between the two of them? That means I really need to work with angle C and angle D, right? So let's go to our given information. So I'm now given angle B is congruent to angle D, which means I have one arc mark for that one as well. Given. Now, is there any way, what can I do with 2 and 3? That's right. I can get the fact that angle C is congruent to angle D by the transitive property. Remember, it's a connector. They both have congruent to angle B, so I know they're congruent to each other. Now look, guys, look at the blue marks I made. Did I make that Z shape? Are angle C and angle D also alternate interior angles? Right. Are they congruent? Yes. So if alternate interior angles are congruent, what do I know about these two? That's right. They're going to be parallel. So we're at our very last statement. We know segment BC is parallel to segment DE because if alternate interior angles are congruent, then I have parallel lines. That's also called what? What do we call that one? Converse of alternate interior angles theorem. I prefer the first way I wrote it down. All right, hopefully that helps you guys finish up your notes. And I'll be able to get these loaded. For some reason, YouTube is messing up right now, but I'll get it up there for you guys. All right, have a great night. Happy studying for your quiz.